Hi there. Welcome to another edition of YugabyteDB Tech Talk series. My name is Sid Choudhury, and today I'm going to walk you through fault tolerance in YSQL, which is YugabyteDB's PostgreSQL compatible API. Let's dive right in. First is, what is YugabyteDB? It's actually a transactional planet-scale database for building high-performance cloud services. What does that mean? It means that YugabyteDB is actually built ground up for the era of cloud-native infrastructure and containers with native support for NoSQL and SQL APIs in a single operational database. From an architecture standpoint, YugabyteDB is comprised of two layers. The top layer is the language layer. We have implementation of three popular APIs. First is our YSQL, which is Cassandra compatible. Second is Redis, which is Redis compatible. And the third is the focus of this talk, which is YSQL, which is PostgreSQL compatible. Underneath this language layer is a common storage and replication architecture, or the core engine of the database, that is built on top of DocDB storage, Raft-based distributed consensus replication, and finally a global transaction manager for supporting distributed multi-shard, multi-key operations and transactions. Why is YSQL important? It's important for multiple reasons. First and foremost is the ability to get linear scale while continuing to use a SQL API, so that you can keep adding nodes and your write scalability as well as read scalability can continue to increase, and throughput can continue to increase. So you can serve your end users and applications so much better than before. Second is the ability to do geo-distributed clusters with global consistency across multiple regions, so that you can tolerate geographic disasters in a given region, as well as bring data close to your users and thereby reduce their perceived latency. With those things out of our way, I'm going to walk you through the demo of how fault tolerance is achieved in YSQL. Let me go to our docs website, and this is docs.yugabytedb.com. In here, we have an explore section. Let me click on that. And in there is a PostgreSQL section where we talk about all the features that are important to YSQL. And I click on that, and there is the second section is fault tolerance. So let me go in there. And there you can see that we have tabs for Mac and Linux. And you can use the standard YugabyteDB binary on either of these operating systems and get going directly on your laptop. So that's what I'm going to do. I'm going to make sure to create a new universe, but I'll start with destroying anything old that I may be having. So let me do that. Clearly, I don't have anything running. That's great. Let me go to and create a net new universe, which is using this enable Postgres as a flag. And there you see that we are able to create a new cluster, and I can run ybctl status to see the status of this cluster. There are three masters, three T servers, and the Postgres query router. I can also go to the localhost 7000 UI and see the configuration of the cluster on a user interface. The replication factor is 3. That means each copy of data or each record is replicated 3 times. And there are 3 nodes that are actually data nodes that are housing the data. There are no user tables yet. We'll go about solving that. So then you're going to download a sample apps jar, which is a Java application with a SQL key value workload that we are going to use. I had previously downloaded that, so all I'm going to do is, and we can see this is YB sample apps jar. I had previously downloaded. So all I'm going to do is actually simply run the sample application. And there you go, the application is starting. It's going to create a new PostgreSQL key value table in the system, and it's going to start doing a bunch of key value inserts and reads on top of that. we can observe that this table is now created by looking at the num user tables and see all tables in the UI. Now that the system is up and running and it's actually taking active load, we can see that each of the nodes are sort of evenly getting reads and writes being served out of them. Now, the big question in fault tolerance is what happens when actually one node dies or it gets partitioned off in a multi-region setup, because we are talking about internet's wide area network, which is inherently unreliable and sometimes has high latency. So I'm going to simulate that environment by simply removing one of the nodes out of the system, and I can see that so before that, here is the app that is running. Fine. So let me remove the node. So now the cluster is running at only 2 nodes. But since it's a distributed consensus-based replication architecture, 2 nodes are good enough to continue to process the workload that is being thrown at this node. Now, let me go to the UI and see. As you can see, the time since heartbeat for the 3rd node is starting to shoot up. This node is no longer being reachable from the masters, which are monitoring the behavior of each of the T servers. And at the 60-second time frame, as we've noted here, the master is going to mark this node as dead, and it's going to move on, and it's going to recreate the lost tablets in the remaining 2 nodes, and so that we get back to a replication factor 3, and we keep moving on. Now, if we look at the application, more importantly, we see that the application is running uninterrupted. It's going as if almost nothing has happened, because that loss of the node hasn't really impacted the application. And if it's a temporary outage, you can clearly bring the application, bring the node back on and get going. Now, just to prove the point that in a replication factor 3 system, the loss of a second node will actually lead to write unavailability. So let me go ahead and remove the second node out of the system. And if I go back here, this first node is now dead, and the time since heartbeat for the second node is starting to shoot up. Now, there is only one node in this system, and the write path is no longer able to establish quorum, which means it is not able to commit the data at least 2 nodes, since there is only 1 node alive. And we can see the write and read throughput has now come down to 0. The cluster is essentially not able to take any writes and reads at this point of time. Actually, you could have configured the sample app to take just reads from the existing node, but for now, the cluster has been set up, the application has been set up in such a way that both reads and writes are lost. So, with that, I have actually reached the end of my fault tolerance demo. I want to point out that all the things that I did on my laptop today, you can do it on your own by simply going to docs.yugabytedb.com/latest/quickstart. We have all the various options for you to try. And with that, thank you for joining us today, and see you next time at one of our future tech talks.